Thanks for having me. It's a great conference, and it's always fun to be at UCL. So thanks. The title is a little bombastic, and I won't. So I'm going to go away from it. I can't do everything that I do in this talk usually, so I'm going to go straight to the dynamic part. Okay, so I'm going to talk about dynamics in two ways. And my goal, you'll see, particularly for the market stuff, is to be able to do credible, what I call credible counterfactuals, okay? So I'm going to divide the talk into two parts. There's going to be a single agent dynamic, mostly on consumer choice. So a lot of the people here have thought about that. And then there's going to be the dynamics of markets will be the second part. In both parts, my focus is on better approximating individual behavior by limiting the cognitive requirements, by limiting the amount you have to compute in order to figure out what to do, okay? So in IO, by the way, so most people here are not IO, but in IO, we need dynamics of consumer choice for one major reason is pricing in markets where consumer choice is dynamic, durable goods, experience goods, network goods, pricing equations depend on the dynamics. So our standard pricing equations don't work so well. The other thing is we now have increasing ability on panel data, so we should be able to get a handle on that, on discrete choices. So I'm going to distinguish two situations in single agent dynamics. One where the perceptions of the future are integral to understanding behavior. So there's been a lot of work on that. You know, I don't want to make it, it's clearly the important thing when there's investment decisions. Okay, I'm not going to talk about that. The rest of the conference did talk about that pretty much. So I'm going away. I want to think about decisions where the implication of a bad choice, okay, it can be reversed if something happens, okay? Repeated evaluations might be cognitively difficult, okay? So the cost of doing the repeated evaluations might rival the benefits you get from a switch, okay? So that leads you to the standard models of inattention and switching costs, okay? And once you do that, the individual choice depends both on his preferences, but also on his past choices, because they're switching costs, okay? So some of the determinants of preferences are not going to be observed. So there's switching costs and there's preferences. Some of the determinants of preferences are not going to be observed. And if they're not observed and we go over the panel over time, they're going to be correlated with your last choice, okay? So in the case I'm doing, which is going to be prices in health insurance, okay? You know, you ask the question, in the US, there's a big worry about people not being responsive to prices in health insurance, okay? You could ask that two questions. One is, maybe they're just not paying attention or they don't care about price, or maybe they just like their last choice. And I want to be able to distinguish between those things, okay? If the unobserved preferences don't change much over time, okay, then you might say, well, if I use individual and choice-specific fixed effects, so every individual has a different fixed effect for every choice, okay? I'm going to show you how to do that. But, you know, the implicit assumption, I'm going to have to look over sequences of choices. I have to see people switching, okay? So the implicit assumption is, you know, these individual specific fixed effects don't change much over time. So I'm going to use very short time intervals. I'm going to worry about the environment of the individual changing or not, okay? So what I'm doing by going to individual specific choice specific fixed effects, okay, it's very similar to what we do in continuous choice models, where there's a between analysis and a within analysis, okay? So that's what I'm going to be doing here. We know that in all the social sciences, differences between firms or between people are determined by very different things than differences in people over time, and that's where I'm trying to go, okay? Okay, so I'm going to do insurance choice. I'm working with Romney Care. This was the predecessor to the Affordable Care Act in the United States. It's for low-income people. You have to have income at least below 3 times the poverty line. In order to do what I'm going to do, I need switches. I'm going to follow people over time and ask when they switch. Okay. So I need I need two periods. I need two switches for an upper bound, but only one switch for a lower bound. I'll give you the intuition why that works. The way that I'm going to attack the data is I'm going to break the data into cells by all the observable characteristics. So there's tons of cells. Okay. And I'm going to look within cell. Okay. First of all, I'm going to drop all the people out who change regions or change the networks or anything like that. And then I'm going to only look within cell. So I'm only looking at people with the same characteristics. I'm comparing the proportion who switch and the proportion who don't for people with the same observable characteristics. But not exactly the same, but I'm doing the best I can. Okay. So here's the utility function. Just to show you that basic assumption that's going to go on here is these are going to be totally non-parametric, okay? But it's going to be stationary over time, the same distribution of epsilon in every period, okay? What's the lambda di are the fixed effect. They're totally arbitrary, okay? And then there's a gamma I, which is the price coefficient, which is also arbitrary. It can vary arbitrarily across people. And the thing I'm really interested in is this kappa zero. I'm going to generalize at the end, but the kappa zero, what kappa zero is the cost of switching relative to income, relative to a person's ability, his own preferences for price or income, okay? So that's what initially I'm going to assume is constant across people. Okay, good. I already told you this. Okay. Okay. Everything I do is just going to be revealed preference. Okay. That's all I'm doing. Okay. So, but I'm only going to be able to get bounds. So I have to use moment inequalities. Okay. So where are the bounds coming from? So I'm first all going to give you what the upper bound is. I can do this math, and I'm not going to do the math. You wouldn't understand it. But it's just easy to understand what's going on. Okay. Take a group of agents who are at choice C in period T minus 2. And then something happens, their price of C goes up relative to other things, and they switch out to D, or I don't care where they switch out to, okay? So if kappa is large enough, okay, they're going to stay at D in the next period. Give me any price change, I can give you the kappa that needs to be large enough for them to stay at D in the next period, okay? Take the given price changes that are in the data, okay, and ask, what kappa would it have to be to stay there, okay? Now, say that was reversed for the proportion that to stay there was less than the proportion should be for that kappa, then you have a contrapositive, okay? If kappa is greater than this, they have to be this, okay? If they didn't do this, kappa has to be less than that. That's my upper bound, okay? I can do a similar thing for the lower bound, okay? So take a group of agents who are at C at T minus 3, okay? And then they choose C in T minus 2. But then something happens in T minus 1 and they switch out. Finally, in period T, the price of C goes down below the initial price, okay? And they don't switch back, okay? In the initial period, there was no switching costs because they were at C and then they chose C, okay? In period T minus 1, there was a switching cost. They were at D already. Price of C went down and they didn't switch back. Okay, so the switching cost must have been higher than that difference in prices. That's my lower bound. Okay, good. That's it. So here's insurance choice. That's what I said. I'm looking at a choice. I don't think you should do this for every choice, but I'm looking for a choice where you don't do every period. Okay, you don't recompute every period. It depends on the last period. And then when something happens, that's the epsilons or the prices, okay, I might switch. So if you like it, yeah, they're myopic, if you want to look at it that way. Okay, but they're myopic conditional on past choices. And the reason they're myopic is it doesn't make sense to recompute value functions every period. Okay, that's the argument. So it's like you go choose ketchup. Okay, every time you choose a different ketchup, okay, you don't recompute what your future will be after tasting this ketchup, okay? And health choice, it's a little bit different, but the complexity, you can revert, if you get cancer, you can, in the United States, you can reverse your insurer. Okay. To actually evaluate a new insurance policy is complicated. That's all I'm saying. So you might want to look this way. I don't think you should do it. I worked on the other part for a long time. Okay. So, okay. Here's the results. Okay. So I want to point out that most of the models on health insurance choice are just these models without fixed effects. Okay. So exactly this data was used in a paper in the AER, and the kappa coefficient that they got was $1,164. They had a little slightly different cut of the data than we're using. It was a very good paper in the AR, by the way. Everything else about it was very good. Okay. And we used exactly our variables, and we got $1,019 for exactly what they computed. Okay. When we do it our way, by the way, this is all Bayesian bootstrap. I'm not going to talk about the econometrics. Okay. It's really simple. You just draw samples and see if they satisfy the inequalities. Okay. We're going to stick with can you see this? Yes. We're going to stick with 99% confidence intervals here because it doesn't matter whether you do 95 or 99 when 50. We're going to do 50, minimum cell size 50 and 450, 78 to 450 for these things. So then the only change we're going to make now, so that's half of what they got before. Okay, less than half, but it's a pretty wide confidence interval. Okay, confidence set. Okay. If you do split up people into income groups, we already split, remember, the cells are already defined by income groups and where you were and everything else, okay? Split them up further in just the switching cost coefficient. So the ratio, the way I treat switching costs relative to my income differs with the income group. So the kappa differs now. That's surprising to us. This is a result of a request by a referee. Okay, surprising to us, this really mattered. You're now really, the confidence interval for the high income and low income group don't intersect. Okay, and when you do it further by whether you were sick or not, so there's a median sickness, and you could go from one side of sickness to another side. It gets even. Even within the income group, there's a difference. Remember, this is a very low income population. Okay, if you get sick, it probably means that your future income is bad also. Okay, and now people switch at very low price changes. Okay, so that's the first paper. Okay, without the econometrics, it's the only thing extra in that is we do counterfactuals, and it makes a huge difference. By the way, the difference matters the longer you predict out. Because if you make a mistake this period, you get the wrong number of people. So if you're predicting 2 periods, you start with the wrong people in the first in the second period, and it just gets worse all the time. Okay. Yes. Well, we didn't do the cell stuff with ours, and we got 1,000 also. Maybe it's got to do with the cell. The kappa coefficient is very different. Okay, that's the one. Okay, that was 1,000, and we get 450. And if you go to lower income groups, it's much less. Okay, so that's one aspect of complexity that I think there are cases, and I don't mean all cases, but there are cases where it's useful to look at it this way, and it's very simple to do. Now I want to look at market evolution. So in IO, so this is largely a labor public group, but in IO, we have to deal with the evolution of markets. How do markets respond to a change in their environment? Okay. And we've been typically using, including myself, okay, state variables, which evolve as a Markov process, but there's going to be a lot of them because there's a lot of firms, and each firm has a set of state variables, okay? And the equilibrium is some form of Markov perfection. What does Markov perfection mean? It just means I'm doing, given what I know, these vector of state variables, I'm doing the best I can given what everybody else is doing, okay? So you're choosing investment, giving the best you can given what everybody else is doing. The complexity of the perfectness assumption in these contexts has led about doubts to the ability to mimic behavior. It's if you write down these models for a typical IO, I promise you that a good example will be what the one I get to. Nobody will be able to compute this for 50 years. So nobody's actually doing it. Okay. That doesn't mean it's not the best approximation available, but there might be a better one. Okay. And it led to implementation problems for researchers. And I'm not going to go into that, but it was problematic. So there are ways to circumvent this that the theorists use, and like they assume asymmetric information. If you do that, the computational problem gets squared, okay? Because the problem becomes, I have to have the right posterior for what all my competitors are going to do, and they're maximizing their value functions, and it just makes it much worse than the standard thing. Okay. So both theory and empirical work have worked on this, and we're not the first ones to think about it. The theorists, and there's a lot of it, they go to weaker notions of equilibrium that doesn't require all these computations, okay? Or to some learning process, okay? Where you don't go right to equilibrium, but they tell you how you learn from period to period and how to update. Okay, and there's a lot of papers. And the difference between those papers and what I'm going to do here is, for the most part, the theorists, and including actually the empirical work, some of which I did, what it did, they're theorists, right? So what are they interested in learning about? They're interested in learning about how I learn about the reactions of my competitors. Okay, how do you do that clearly? You do it in a repeated game where nothing's changing in the environment, just the competitors' actions. Is that clear? That doesn't work for IO. We're interested in the dynamics of the market. We're interested in something changed in the market, investment changes, prices changes, everything changes. Okay, so that's the only real difference between what I'm going to do now and what's in the theory stuff. The same ideas play out. It's just that when you do it in a dynamic framework, you need slightly different, you need different assumptions. Okay. So I'm looking for a cognitively less demanding framework. So I'm going to use this experience-based equilibria stuff. So this is what it assumes, okay? It assumes that agents are maximizing the expected discounted value of future net cash flow, the standard thing, okay? Conditional on their perceptions, but their perceptions need not be correct, okay? In equilibrium, okay, and I'm going to do two models, they're going to be partially consistent. What are they going to be consistent with? What is partially? They're going to be consistent with what they've observed in the past. Okay? But that's all they know, what they observed in the past. They have perceptions on everything, but they can only check what they've observed in the past. Okay? Different agents can have different information sets. So there's asymmetric information. And the theory doesn't constrain what they be. But it's the agent only has to condition on his or her own information set, not on everything in the market. Okay. This greatly confuses, it reduces cognitive requirements, but in equilibrium, still in those what they know, they have to be partially consistent on. Okay. The problem with the theory was done and published a long time ago. The problem with the theory, it's silent on the state variables. Just says if there are these state variables, they're information sets of the various firms. Okay, it doesn't tell you what they are, and empirical work has to do something about that. Okay, so that's where we are today. Okay, so I'm going to give you two models. One model is an empirical model. It assumes agents are maximizing behavior, but doesn't assume anything on perceptions. So what I see, I'm going to do advertising. So I see the guy advertising, and I'm thinking that choice of advertising maximizes his perceptions. Those perceptions, or her perception, those perceptions need not be correct. Okay. Then what I'm going to do is I'm going to use that model to determine what are the state variables of the problem. What are these firms responding to? Okay, in my data, what I can see in my data, and a serially correlated unobserved state to account for things that they care about that I don't see in my data. Okay. And I'm going to figure out other things about the data that I need to be consistent with, like exit and simultaneity and stuff like that. Then I'm going to bring an equilibrium model, which is exactly the experience-based equilibrium model. Okay. I now know the state variables and the serially correlated unobserved states. Is that clear? And I can compute an equilibrium. And I'm going to compare it to the actual data. Okay, to the empirical model and to the data. Okay, and then I'm going to do a counterfactual. Okay, where the counterfactual looks at the equilibrium in the two, there are two ways to do counterfactuals in these models, okay? One is you assume you're at equilibrium, both in the counterfactual and in the factual. That's what I'm going to do. It's the easy way, okay? The hard way, but probably the more realistic way, is to use learning theory to go from one equilibrium to another equilibrium. When learning theory stops, it stops at a Nash equilibrium, typically on the learning model, okay? Okay. So what we were after is an ability to do counterfactuals for changing market circumstances, okay? So I'm going to do advertising of pharmaceuticals. I'll talk about it in a second, provided I have time. I actually am going pretty fast, so so people can ask questions, by the way. Yes, that's the only. So on the points that I visit repeatedly, okay. So what happens in the experience-based equilibria? I'm going to hit certain points. Okay, I'm going to touch certain points. If I touch them, I see what everybody else does. I can learn what my profits would be from doing different things because I see what everybody else does at those points. Okay, so at those points, you know, when I converge or when I get to equilibrium, okay, I'm doing everything exactly right. Even though I don't know why they're doing what they're doing, I'm getting it exactly right. And I'm only getting it exactly right because I can read it off the data. Okay, that's the only difference, but not on all the points, just on, okay? And that generates problems. So I don't know if I'll get to it, but that generates problems. Okay, so what happened before in empirical work and IO? There are two kinds of empirical work that tried to do sort of counterfactual-like things. Most of it is, and I don't want to make it, we learn from both of them, okay? So I don't want to, but one is you see a perturbation by a subgroup of the agents, okay? And you see what happens. So in my case, I can go to the example that I'm going to do is advertising for pharmaceuticals. Let me just note, there's only two countries in the world that allow advertising for pharmaceuticals, the United States and New Zealand. And it was a big argument in the United States. Prior to 1997, they didn't allow it, and then they allowed a partial form of it, and now they allow it, okay? This is what you see on TV mostly. 75% of it is on TV, you know, you're feeling down and out, maybe you should go see a doctor and stuff like that. And in particular, we have, you know, whatever it is that you want to see. If it's, okay. Why did I go there? Yeah. So the work on advertising that was prior to this, what it did is it said, look, you know, prices of TV ads went up during when the presidential election was on. Let's look at the difference in the two periods during a presidential election. It's not a stupid thing to do. Or there's MSAs, there's these environments for TV where, you know, the choices they go on advertising on one side of the border and not on the other side of the border, and we look at the difference. So those things, they're useful, you shouldn't get me wrong, but they're not equilibrium responses. Okay, and in equilibrium, it's not only my advertising that changes, it's everybody else's advertising and my response to everybody else's advertising. Okay, and you think, you know, as IO economists think, at least maybe you guys don't think, but we think that, you know, equilibrium matters, that firms respond to each other. The other way of doing this is approximations. So there's all this stuff on oblivious equilibrium and more, okay, and some that you're learning in this thing. The problem with using approximations to do a counterfactual is you're approximating the wrong environment. You're approximating the environment before the counterfactual was there. So, you know, in the advertising, so the only thing you've got in the United States is data on when there was advertising. Now we're going to kill advertising. You're going to use the same approximation for when the data, okay, so that's the issue, okay? Okay, so here's direct-to-consumer advertising. I'm going to tell you, it's important just monetarily. Pharmaceuticals are, I keep telling my students this, and some of whom are in the audience, pharmaceutical, if there's one industry in the United States or probably in the world that generates more consumer surplus per dollar invested, it's probably pharmaceuticals. So you want to worry about it, okay? Because it's not internalized. What you gain is not from taking a pill when you're really sick. It's nothing like, okay. So there's calculations on this in this paper by Kate Ho and I, which just came out in the Proceedings National Academy, okay? But the differences are huge, okay? So what happened with direct-to-consumer advertising? So there are two kinds of advertising. Okay. I'm going too quick. If you can follow me, you're doing well. One kind is this direct-to-consumer stuff, which you see on TV, okay? And the other stuff is detailing, which is much bigger. And it's when the, you know, when Merck sends out somebody to convince the doctors to use its pill, okay? That's much bigger. I'm going to get to it, okay? So what were the arguments? Just briefly, the arguments against doing direct-to-consumer advertising, which have dominated in Europe and in Australia and Japan and everywhere else that's at least developed countries, is it gives incentives for excessive use, both to the doctor and to the patient. But moreover, the argument is, so when you, let me take ulcers, okay, which is a big thing. Ulcers almost disappeared now, but it used to be a big deal. If you go to the doctor, ulcers is a digestive disease, okay? If you start having heartburn and stuff like that, it can develop into ulcers if you don't take pills, okay? Heartburn might not bug you, okay? But ulcers is a very serious disease. You're going to be in the hospital. They're going to take part of your body out, and you're never going to be the same, okay? So that's what happens. Ulcers almost disappeared because of the, with two things, really. One, they discovered an acid that does it. But the other thing is the pill, they can give you pills that if you take a pill a day, okay, you're not going to get ulcers, okay? And, you know, those pills, you've heard of them, Zantac, Axid, Pepsid, okay? And what this was what the companies argued. They argued, you know, you don't want to allow direct-to-consumer advertising, okay? Who gets ulcers, okay? People who eat very rich foods and don't see doctors. Who are those people? They're poor people, okay? If you tell them, they watch TV, if you tell them to go see the doctor, they'll go see the doctor, and that's going to just help everybody, including the national health system, okay? Because people aren't going to get ulcers, okay? So that was the argument, okay? That's the for argument for direct-to-consumer advertising, okay? Again, you also want to worry about its impact on profits. The reason you want to worry about the impact on profits is because that's the incentive to do R&D. 80% of the R&D, 20% of the R&D of this industry is done by the National Institute of Health. 80% of it is done by private firms. If you cut back significantly on profits, you're going to cut back. Their fiduciary responsibility will be to cut back on R&D, and you don't want that to happen, okay? Okay, what do we want to learn? So we want to learn how to analyze a counterfactual for this, okay? So the question, one question you might ask is, if to analyze what happens when you cut DTC, do you have to figure out what detailing response will be? Okay. You know, you might think that what the DTC does is it tells them to go see the doctor. If the to go see the doctor and ask for Pepsid, okay? If the doctor doesn't like Pepsid, if the detailing guy didn't convince him of Pepsid, he won't give you Pepsid. Is that clear? So you might think that they're related, okay? It is true also, we want to know the effect on profit. I'm going to show you oh, I guess did I go over the numbers? Did I put in numbers? It works out that detailing and DTC are highly correlated, both across industries and within industries. I thought I had a picture here. Oh, there it is. These are different industries. Okay, we're going to study 4 markets, 4 of the highest direct-to-consumer advertising markets. And the dots are different, colors are different markets. I mean, you can see that detailing and DTC are highly correlated. These are firms' observations. The other thing about these markets, by the way, is they're highly concentrated, and the concentration, the top 4 firms are all the firms that do detailing and DTC. Okay. And you can see the amount of detailing and DTC they do. The amount of detailing that the top 4 do is about 10 times the average. And the amount of DTC is about 20 times the average. It's huge. Okay. It's these 4 firms that are doing things. So you might want to know from an IO point of view, if you stop DTC, will the market structure change, and will that change prices and everything else because the market structure changes? The other thing is you might want to look at differences across markets. This is a case where we think there probably are. So there are diseases where, you really don't go see the doctor and ask for a drug unless it's not self-evident. Okay, so cholesterol. Okay, you might go to your doctor. The doctor might ask you if your parents had heart disease. If they do, he'll give you a lipid test, and then you might get. But if you didn't, you don't know you have a cholesterol problem until a doctor tells you and you do a test. Okay. Similarly, with depression, the literature says there's a lack of mental awareness when people are depressed. Okay, and so if you see it on TV that you're not feeling well, maybe you should go see the doctor. It might induce you to do that. Okay. So those are 2 of our 4 markets. The other 2 markets are asthma and ulcers. Asthma, asthma is self-evident. You wake up in the morning, you can't breathe, or there's pollen and you really can't breathe. You really do have to go to a doctor. There's no issue about it. You know that. And similarly, if you get to ulcers, hopefully you won't, but if you get to ulcers and haven't protected yourself yet, you're going to know you're sick. Okay, because you can't digest anything after a while. Okay, and so you go there. So there's likely the impact of something on TV telling you that you might need a drug will differ between these industries. Okay. Here is the steps in the analysis. I don't even need to know how much time do I have. I did. So here's how it goes. You estimate a BLP demand system. I don't know if the public and labor guys know what a BLP demand system is, but the only thing about doing that on aggregate data, the good thing about it is it fits exactly. Okay, it's defined so that C, the unobserved term, makes shares fit exactly. Okay, so that's the reason it works. Okay. This is not linear. This is exactly right. Okay. Then there's so what we did is we put a lot of X's into the thing and random coefficients, everything, and then we found out what it doesn't explain. So you can do the contraction mapping, which gives you the part that there's an unobservable, which makes it fit exactly. And there's a simple way of inverting to get those unobservables. Okay. And then we call them C. I think this is now general notation. And then we let these C's be a function of advertising. Okay, and we estimate those functions. You have to use instruments and stuff, but we estimate those functions. Okay, and that's the impact of advertising on demand. That's what we're using. Okay, then we formulate and estimate a model for advertising choice. It's empirical. Okay, so we just go to the data, we look at what advertising depends upon, and we allow for a serially correlated error. Okay, and that's two equations now because it's detailing and DTC. Okay. And then I'll show you that relationship of that to the data, how well it fits. And then I'm going to compute equilibrium policy and compute and analyze shutting down direct-to-consumer advertising. So I'm not going to show you all of that. I'm just going to tell you I did it. Okay, you're going to have to believe me. We do want to do one more, let me just say, and that's why part of the reason why it's not out. The other part of the reason it's not out is just took forever. We want to do one more, which is we want to shut down advertising, DTCA, by the firms. Let the FDA, the Food and Drug Administration, advertise, but not advertise the name of the drug. Just say, if you have indigestion, you should go see a doctor. He can give you a pill, which is cheap, okay? And actually, I think for some of them, for cholesterol, it's paid by the government, okay? The statins are paid by the government. You don't pay anything. Okay. It's cheap. And if you don't go to the doctor, you're going to get ulcers. You have a very high probability of getting ulcers, and then you're going to be really sick. Okay. But no names of Pepsid, Axid, just that. Okay. And then fund it through a through a tax on sales of those drugs, of the firms. Okay, and that's where we were trying to go. Okay, we're not there yet. These are the 4 drugs. I showed you this before. This is the picture of that. The only thing I think you need to know for this, I'm gonna say you should believe me on demand. It's reasonable and it works, and there's lots of parameters. The thing important about advertising, there are 2 important things about it, but the most important is it works out, and we tried this not to happen. Okay, it works out that detailing and DTC are strategic complements. That is, if I increase DTC, the marginal product of detailing goes up, and vice versa. Is that clear? That just comes out of the data wants that. Okay, and we tried to reverse it. The data rejects the reversion. Okay, and the errors are certainly correlated. Okay, so then we asked, you know, what does advertising depend upon in our observables, in our data? Okay, so the thing that it depended on most, which actually in retrospect I should have thought of 100 years ago, was the derivative of profits with respect to advertising. Why should I have thought of that? The value function, it's impossible to calculate. It's just too complicated. Is that clear? What is the value function? It's the iterates of the profit function. It's profits today plus delta times profits tomorrow plus delta squared times profits the next day. The closest thing to the value function, which you can't compute, is the profit function. Okay, I think I blew this. Okay, so the other thing was time to loss of patent. So that was very important. It came in every regret in all both things in all markets. Time to loss of patent exclusivity. As you get close to the end of the patent life, advertising goes away. Okay, and the advertising of competitors in the same therapeutic class. So there are therapeutic. I don't want to get into the. In each of these drugs, there are therapeutic classes. Some don't work for some people and some work for others. Is that clear? Within the therapeutic class, there are a bunch of drugs. They are differentiated not by the active ingredient so much as by things like release time and adhesives and things which can affect you, okay, can affect different people differently, but the active ingredient is the same. So you get, you know, you feel nausea or you feel something like that, and this switched within the things. So the advertising equation, by the way, we estimate the marginal cost of each product in it. So the way IO typically estimates marginal cost when it's not available is you use the Nash pricing equation. Prices depend on marginal cost plus a markup term. Okay, that didn't work. Okay, I can give you here. It's not surprising when you know enough about the industry, but it didn't work. But if you just do the dynamic advertising equation, okay, on average it has to equal 0 over the if the model is approximately right given their perceptions. Is that clear? So there's a value of the cost which makes the dynamic expected discount value of profits exactly equal to 0 for each one, and that's how we got it. And that did work. Okay. And so, and it also estimates separate system and dynamic parameters. Okay, then we're going to go, I'm going to go now to the, I can show you, that's the data on, you should only look at the bottom, the top one is. So what's happening here is we're using the empirical model, just the empirical model, okay? We're starting at the initial period in the data for this guy, okay? And then we're predicting quarter one, okay? And then given the prediction for quarter one, we're predicting quarter two, and quarter two predicting quarter three over 38 periods, and this is what you get. Okay, this is for detailing, and this is for DTC. Okay, so that's the fit of the empirical model. It's not terrible, it's not great, you know, but it's there, okay? Now I'm gonna, okay, so what we do then is we compute a market equilibrium. We have a fancy way of computing it that's really quick, but I'm gonna make an assumption when I do my counterfactual, which is not a great assumption, which is I'm gonna say the counterfactual is in equilibrium in every period. So we change I'm gonna start at initial period, okay? And I'm gonna say this is what happened in the data. what would happen if they were doing an experience-based equilibrium and they were at equilibrium in every period thereafter. Is that clear? Yeah, you might think that they'd have to learn to change. Okay, so first we do it for in the data, and then we do it for we kill DTC and we do another equilibrium. Is that clear? And I'm going to compare the equilibrium without DTC to the equilibrium with DTC. Okay, but you might think that's not strictly kosher because they might not figure out what the equilibrium was instantaneously. Okay, that's where learning theory would be helpful. And there's multiple equilibria in this. I don't want to get into it. If somebody wants to tell, I can tell you there's more. So Bayesian perfect is a special case of experience-based equilibrium. Bayesian perfect has multiplicity. We have more multiplicity. If you're interested, I can tell you why there's more, but I'm not going to do it now. Okay. So we're going to pick out an equilibria, and we do that in two ways. One, we start where everybody started. So we let history pick out what equilibria are possible. Okay. And then within the possible equilibria, we look at something called boundary consistent equilibria. Remember, this is, you get the right thing not on everywhere. Okay. So there are points that you get to where this is a Markov process, where if you do the optimal thing, you're going to stay in the recurrent class of the thing with probability 1 forever. But there's a feasible thing that can take you outside. Okay. So if I play the optimal thing, I'm only going to see things that I see many times. Okay. And I'll get it right. But I could play something feasible that takes me outside of here. Is that clear? And there's nothing saying that stuff outside is right or wrong because you didn't hit it. You didn't visit it enough times. Is that clear? And if you have different perceptions on the outside, you can have different insights. Okay. So, and so the boundary consistent makes sure your perceptions on the feasible but inoptimal policies are right a certain amount. Okay, they're right for one step. Okay, so that I already showed you. This is the comparison of the empirical one of the EBE against the empirical model. So you can see this is this one is EBE against the empirical model. You know, it's not the same. What can I tell you? But it's not that different, okay? Actually, in the new stuff, it's a little bit more different than that, but not that much. And this is EBE against the data, okay? So that's not so different from the empirical model against the data, okay? But it is a little different. It's a little bit more variant. So that was detailing, and this is DTC. Okay. DTC had much less data than detailing, only 1/4 of the data of detailing. So the model becomes very important because there's less data. Okay. And this is the equilibrium DTC and detailing together. And those are, the dots are real data. The blue dots are data, and the red are the predictions of the model. These are the probability of 0 DTC given detailing. The axes are wrong, but okay. Okay, here's what happens. Stop. I can just give you the answers. Okay. Yeah, it's only dinner. No, I'm joking. Detailing falls dramatically. If you cut down DTC, detailing falls dramatically. Okay. Especially for cholesterol, and, you know, but for all of them. Profits changes. The fall are all concentrated in the large firms. So we're getting a much more equal distribution of sales after this, okay? Where markets where DTC was needed to draw consumers, cholesterol and depression, the loss in profits was 8 to 10%. That's a significant loss of profits. In asthma, profits actually went up. Okay, they were doing advertising because their competitors were doing advertising. Okay, if you just take away the cost of advertising, then their detailing also goes down. Okay, and they just end up saving money. Okay, and in ulcers, it stays about the same. They're about equal. So it's important in those markets where people don't know, that they have the disease or are unwilling to go to the doctor, but not so important in other markets. This is the detailing with and without. We're still, you can see the differences, but the blue is cholesterol, so you can see it falling, and the orange is asthma, and you can see it doesn't fall so much. Okay. The other thing is, and this I wanted another number which I never brought in. So the other thing you're worried about is the share of the sick population who are taking the drugs. Okay, because okay. On average, and I'll tell you why I think this is the wrong number. It didn't go down that much, 1.1 to 3.1%. The reason I hesitate to tell you this is because the average is over all these years. And as you get towards the end, it gets bigger and bigger and bigger. And I should have really plotted the whole thing out, and I just didn't have time to do it before today. So I wouldn't take too much away from the smallness of the effect on consumer supply. Also, there's also the problem, by the way, the guys who stopped taking it might have been guys who shouldn't have taken it in the first place. So there's that problem. I can't distinguish in my data between those things. Okay. That's it. Thank you.